So let's take a look at this graph, or let's try and graph this without a graphing calculator. We're going to, number one, look at the domain, and we can see that the denominator is x, so that means we have a restriction on the domain. X cannot equal 0. Next one is the intercepts, and since x can't equal 0, there is no y-intercept. And if in order to figure out the x-intercept, y would have to be 0. So 0 equals e to the x over x. And the only way to make that 0 is to make e to the x 0. And our graph of y equals e to the x looks like this, which we know will never hit the x-axis. So there is no x-intercept either. So that what that means is that our graph isn't going to cross either of the axes. There is no symmetry. And there's no symmetry because e to the x is not a symmetrical function to begin with. And now we're going to do horizontal and vertical asymptotes. I didn't mention that in my analysis of the trig one because there were no asymptotes, but in this case there will be. So first of all, let's deal with the vertical asymptotes, which will happen at x equals 0. And if I take the limit as x approaches 0 from the right of e to the x over x, so what happens there is if this is positive numbers, so e to the x will be always positive, and you're dividing by a positive number, so you know it'll head to positive infinity. And for the other side, the limit as x approaches 0 from the left, e to the x over x. So again, the numerator is going to be positive even if you're putting in smaller values of negative values of x, and the bottom will be negative, which means it's going to go to negative infinity. So if I think about the graph, if I'm heading to, there's going to be an asymptote at x equals 0, and if you're coming from the right, it's going to go to positive infinity, and from the left, it's negative infinity. So the next step is to figure out the derivatives and figure out where it's increasing and decreasing. So let's look at the function again. And to take the derivative, I'm going to use the quotient rule. So the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. And if I factor that, I get e to the x out. I get a simple one that I can figure out where is it the critical points. In other words, where is it going to equal 0? It's going to equal 0 when e to the x equals 1, because this will be 0. It doesn't exist at 0, so I'm going to put a hollow dot there. So I've got my critical points, and now I'm going to put the rest on the number line. So e to the x is always positive. X squared is always positive. And x minus 1 switches at 1. So it'll be positive on this side and negative on this side. So that's x minus 1. So that means it's decreasing in this area, decreasing in this area, increasing in this area. So the function will look like this: decreasing, decreasing, and increasing, which tells you there is a minimum value here at x equals 1. If I plug 1 back into here, I get y equals e. There is no value for x equals 0 because that's not in the domain. So the next step is to figure out the second derivative. And the second derivative is equal to, let's put the first derivative on here again. That's the first derivative. So we're going to have to take the derivative of the top. And notice the top is a product rule. So I'm just going to do this on the side. The derivative of the numerator is e to the x times the derivative of the first piece, which is e to the x, times the second piece, plus e to the x times the derivative of the second. So I'm going to simplify that, and it just becomes x e to the x. Now this will simplify when I have to now take the derivative of this. So I'm going to take the derivative of the top, which I've already done. It's x e to the x times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So simplifying this a little bit, it's x cubed e to the x minus 2x e to the x and the x minus 1 and x to the fourth. Now I'm going to factor out an x and an e to the x in the numerator. So I'm factoring out an e to the x and one of these x's, and that leaves me with x squared minus 2 times x minus 1 over x to the fourth. That allows me to cancel this, and I end up with e to the x over x times x squared minus 2x plus 2 over x cubed. So putting this in on a number line, x cubed will switch at 0, so it'll be positive on this side and negative on this side. E to the x is always positive all the way across. And 2x squared minus 2x plus 2 is not factorable. And it's either going to be, and it's also, if you use the quadratic formula, you'd find that there's no solution. So that means it's either always positive or always negative. And if we just plug in x equals any number, you could plug in x equals 0 and you'll see that it's positive. So it's a parabola that sits above the x-axis. And so it's always positive, which means it's positive in this area, which is concave up, negative in this area, concave down. So it's concave up between 0 and infinity, and concave down between negative infinity and 0. So let's put all that together in a graph. We have a asymptote at x equals 0. We know that it's going, the vertical asymptotes look like this. We also know that it has a minimum value at 1 and e, so here we go. And it is it's decreasing between 0 and 1, and then increasing again, and it's decreasing between negative infinity and 0. So that's what it looks like approximately, and then let's double check the concavity. The concavity is it's concave down, concave before 0, and it's concave up after 0. So that makes sense too. And there's no inflection points. So when 2 log x equals 3, which means when log x equals 3 halves, or when x equals e to the 3 halves. So that's where it's going to go from positive to negative, because that's where it's equal to 0. And it might be an inflection point. We will put it on a number line to take a look and see. So I'm just going to rewrite the second derivative here. It was 2 log x minus 3 over x cubed. I've just rewritten the order in the numerator, and I'm going to put this on a number line here. So x cubed, remember we only care from 0 and above, is going to be positive all the way across because x is positive, and 2 log x minus 3 is going to have a switch of sign at e to the 3 halves, and it's going to be larger on the right side of e to the 3 halves and negative on this side, which means its second derivative is negative here and positive here, so it's concave down on this side of e to the 3 halves and concave, oops, drawing it the wrong way, concave up here, and that means there is an inflection point at e to the 3 halves. And when we plug in e to the 3 halves into the equation, the original equation, we will get, let's do that together, y equals log e to the 3 halves over e to the 3 halves. The numerator can be simplified to be 3 halves And so you hear the phone in the background. I'm going to ignore that. We get y is e3 over 2e to the 3/2. So now I'm going to put it all together in a graph, and I will clear the video one more time. Okay, so hopefully you've written down everything as we've been going along. We don't really care about anything on this side because we know the graph has got to be greater than or equal to 0. So actually let me regraph that so that I worry about just giving myself a little bit more room there. And I know that it has an x-intercept at 1. And then I know that it also heads towards negative infinity. There's the horizontal asymptote, and it does, and the vertical asymptote, and I know that the horizontal asymptote